Hello everyone. In this section we're going to talk about fractional equations. Our goal is to solve equations that involve rational polynomials by getting rid of the rational part, so making them just integer related polynomials and no more fractions. You've done this before where the fractions were only numbers. So as an example, we have 2 over x plus 1 minus 1 over x equals negative 2 over x squared plus x. So if you remember, how you get rid of the fractions is to multiply every term by the LCD. Recall that the LCD, least common denominator, is the product of all prime factors raised to their highest degree. So in this case, it's going to be x times x plus 1. So we factor any denominator that we have. So for instance, let me get a marker. X squared plus x becomes x times x plus 1. It has a GCF. So our prime factors are x plus 1 and x, and they are all raised to, at most, the 1. So our LCD is x times x plus 1. So when we multiply, say, our first term by x times x plus 1, the x plus 1's cancel, and we're left with the 2 times the x. For our second one, we multiply 1 over x times x times x plus 1. The x's cancel, and we're left with the negative 1 times x plus 1. On the right-hand side, the LCD is the denominator, so everything cancels, and you're just left with the numerator. When we solve that, we get x equals negative 1. Right, you'll distribute your negative, so 2x minus 1 equals negative 2. X equals, add the 1 over negative 1. Okay. So make sure at this stage that you check your answer, because we're multiplying by a polynomial here, right? We're multiplying by our LCD. We need to make sure that we're not multiplying by 0. If I multiply an equation by 0, everything goes away. So we need to make sure that the LCD is not 0. So we plug in our negative 1, and we notice that we do get 0. And since we do get 0, there's no solution. If I try to plug negative 1 into here, I end up with 2 over 0 plus 1 equals negative 2 over 0. And that is not true in like 5 different ways. Okay, so it's really, really important that our LCD does not become 0 once we've solved for x. We really have to make sure that we're checking our answer. Okay, so let's try another one. 5 over 2n plus 4 equals 3 over 4n. I need to factor. Right, the right-hand side is already factored, but the left-hand side I can take out a 2. So we have 5 over 2 times n plus 2 equals 3 over 4n. Remember that 4 is 2 squared, so our prime factors are 2, which is raised to the 2, n, and n plus 2. So our LCD is 4n times n plus 2. Don't put 8, right? 2 is already part of the 4. So the LCD is 4n times n plus 2. When I multiply my first term by my LCD, I have the 2 gets taken out, and the n plus 2 gets taken out. So I have, right, so let me erase that. So I have the n plus 2, 2 of the 4, so I still need a 2, and the n. So I have 5 times 2n. For my second one, I have the 4n, so I need the n plus 2. So my 3 times n plus 2. Right, then again, we solve it. So 10n equals 3n plus 6. Bring the 3n over. And we get that n is 6 over 7. This does not make the LCD 0, so it is a solution. Remember, the LCD is 4 times n plus 2. 4 is not 0. N, 6 over 7, is not 0. And n plus 2 is not 0. So I don't have to like multiply this out, right? I just know that I have 4 times 6 over 7 times 6 over 7 plus 2. Not 0, not 0, not 0. So I'm good. So 6 over 7 is the solution, assuming that I actually did the math out correctly. Right? Don't forget, you can always plug it into the original equation to make sure it's actually the correct solution, too. So let's try another one. We have 4 over 4 minus x plus 2 equals negative 2 over 3x minus 12 plus a third. So we're going to factor. We've only got one denominator that we can factor. There's a GCF of 3. So we get the following. Our LCD, we have two different factors. We have a 3, and we've got an x minus 4. So notice we have an x minus 4, we have a 4 minus x. It's the same term except the fact that we have a negative. So we're going to think of 4 minus x as negative x minus 4. Okay, and we don't need to include the negative in the LCD. So the LCD is just the 3 and the x minus 4. And then when I multiply everything through it, we'll see where the negative comes up. So in my first term, I have the 4 minus x, which remember is negative x minus 4. So I'm missing the 3, and I'm also missing the negative. So that's why I have a negative 3 here, for the fact that these two are opposite signs. Okay. My 2 needs my entire LCD, so I'm going to multiply by the 3 and by the x minus 4. The first term on the right has the whole LCD, so everything gets canceled, and we've just got the negative 2. And then the last term has the 3, but we need the x minus 4. Okay. And then we're going to solve this for x, so we've got negative 12 plus 6x minus 24 equals negative 2 plus x minus 4. I will clean that up. We'll subtract the x over, so all of our x's together, we have 5 of them. On the left-hand side, we have a negative 36, so I'm going to add the 36 over. On the right-hand side, we have a negative 6, so 5x equals 30, and that will give us x equals 6. Okay. Again, we want to check, does that make our LCD 0? So we have 3 times 6 minus 4, not 0, not 0, I'm good. Again, I should check that 6 actually works, and you should always do that, especially on the test. But I'm going to just tell you right now that I've done it beforehand, and 6 is the actual solution. Okay, so let's try another one. 2 over x squared minus 1 minus 2 over x plus 1 equals 1 over x minus 1. The only factoring I can do is I have a difference of 2 squares here, so I'm going to get x minus 1, x plus 1. The LCD, again, we have two different factors. They are x plus 1, x minus 1. So when I multiply everything through, again, my whole denominator here cancels with my LCD, so I've just got the 2. Here I need the x minus 1, so minus 2 times x minus 1. And then the third one, I need the x plus 1, so 1 times x plus 1. And then solve it, so distribute. Remember the double negative. And then that is, I'm going to add the 2x over to the right to get 3x. And I've got 4 minus 1 is 3. So x should be 1. 1 does make my LCD 0, so that's bad. So there is no solution. Again, if I try to plug in 1, I'm dividing by 0 in 2 different places, so that's bad. Okay, so again, you always have to double check, is it making my LCD 0? That means I'll be dividing by 0 in my original problem. Okay, so let's do this last one. 1 over 2x plus 3 equals 5 over 2x minus 4 over 2x squared plus 3x. The only factoring I can do is there's a GCF of an x in the last term. my LCD, I have a 2, I have an x, I have a 2x plus 3. Okay, so 2 times x times 2x plus 3. I multiply everything by it. And in my first term, the 2x plus 3's cancel, so I'm left with 1 times 2x. In my second term, the 2x's cancel, and I'm left with my numerator times the 2x plus 3. And in my third one, everything but the 2 cancels. So I've got the original -4 and then the 2 from the LCD. And then we will, again, distribute and solve. So 2x equals 10x plus 15 minus 8. Bring the 10x over, -8x equals 7. So x is -7/8. Again, we'll check, does it make my LCD 0? So I'm going to plug it in. This is not 0, this is not 0. 2 times -7/8 is not 3, or -3, so that is also not 0. Right, I don't care what the LCD is, I just need to know if it's 0 or not. Okay, and it's not 0, so I'm good. And again, assuming I did the algebra correctly, -7/8 will be my solution. Okay, so just make sure that you go through this carefully. Make sure you check your answer at the end. Okay, because there's a chance that it could be no solution. Okay, so read through the section, try out the homework, and let me know if you have any questions. Thanks.